Hey, what's up, guys? Another exciting stream. We are going to be doing Enumerables and Streams from the Elixir Getting Started guide. So it should be a lot of fun. Pretty important modules to touch on. Well, the enumerable one for sure. So I'm pretty excited. So I hope everyone's doing well. And yeah, what's up? And let me just go ahead and open up Firefox. And I'll share my screen so you can see what I'm doing. All right. And we'll head over to elixir-lang.org and then the guides. And we're going to be jumping into enumerables and streams. Hopefully everyone can see this. And hopefully our chat is working. Let's find out. There's a little delay, but we'll see if it pops up. Fingers crossed. It feels like it works every other. Sweet, it's working. All right, let's go ahead and just dive right in, I suppose. Enumerables and streams. While Elixir allows us to write recursive code, most operations we perform on collections is done with the help of enum and stream modules. Let's learn how. All right, enumerables. Elixir provides the concept of enumerables and the enum module to work with them. We have already learned two enumerables, lists and maps. All right, so we can use the enum.map for any type that uses the enumerable protocol. So you can see it working here. Let me go ahead and open up the terminal. And I'll make this a little bigger for us. And let's start our IEX shell. So IEX. All right. And so we can use enum.map on a list, and we can also use it on a map. So if we do enum.map, and we pass in our list with values 1, 2, and 3 inside of it, we can then pass in our function here. So we can take each value in the list and we're going to multiply it by 2 and then end and close those parentheses. So we're going to get 2, 4, and 6 back. And then we can also do enum.map with a map. And so if we do percent opening and closing curly braces, and inside we can put our keys. So we can say 1, and then we have to do the equal greater than, and then value 2. So key 1 has the value of 2, and then key 3, we need a space, has the value of 4. And then we can do the same thing here. Comma, and then we can do our function, and we are going to have our key and value here in a tuple, and then we can go ahead and say we want to multiply our key times our value and then close those parentheses. So we're going to take 1 times 2 and then 3 times 4, so we should get 2 and 12 in a list. All right, pretty cool. The enum module provides a huge range of functions to transform, sort, group, filter, and retrieve items from enumerables. It is one of the modules developers use frequently in their Elixir code. For a general overview of all the functions in the enum module, see the enum cheat sheet. And I suggest bookmarking this one. The cheat sheet shows, it's just a good quick reference for all things in the enum module that you'd be using, from filtering, mapping, side effects accumulating. So that's like reduce, aggregations, sorting, like it's a good one. Concatenating and flattening, conversion, duplicates and uniques, indexing, finding, grouping, you get it. So highly recommend checking this out. I'll actually add the enum cheat sheet to the description of this video afterwards, but yeah, it's worth a glance. All right, Elixir also provides ranges. So a range, you can definitely check out range in greater detail here. It is also an enumerable, and a range is when you see things like this, the 1.3, it means it's going to go ahead and map through those values. So if we click on that, you can see 1 in 1.10. So 1 exists inside of that, and so on. So you can check this out, and that's ranges. But anyways, let's play with the example. So if we go ahead and say enum.map, and we pass in a range, so values 1.3, so it's going to go through 1 through 3. And then we can pass in our function here. So each value, we're going to go ahead and multiply by 2. And so we're doing the same thing that we did with our list up here with sending in values 1 through 3 in a list. This is just using a range and doing the same thing. And we're going to get a list returned. So we get 2, 4, and 6 back. And then we can also use a range on our reduce. And if you remember, we touched on reduce a little bit in the last stream. And reduces a list down to 1 value. So you have an accumulator in most circumstances, and that accumulator is the value that gets returned. So if we do 1.3, we're going through 1 through 3, so 1, 2, and 3. And our accumulator is starting at 0. And then we're going to go ahead and use the addition arity2 function. So we can do the shorthand version here where we say with the ampersand, and then we say plus arity2, and that will automatically pass in our accumulator and whichever value we're on and add those together. And so, 1 plus 2 is 3, 3 plus 3 is 6, so we get 6 back. All right. So where was I? All right. So the functions in the Enum module are limited to, as the name says, enumerating values and data structures. For specific operations like inserting and updating particular elements, you may need to reach for the modules specific to the data type. For example, if you want to insert an element at a given position in a list, you should use the list.insertAtArity3 function, as it would make little sense to insert a value into, for example, a range. So yeah, you want to, if you're manipulating a data type, you want to go to that data type's module to do it. Well, not necessarily manipulating, but insert or changing values. So we say the functions in the Enum module are polymorphic because they can work with diverse data types. In particular, the functions in the Enum function can work with any data type that implements the enumerable protocol. We are going to discuss protocols in a later chapter. For now, we are going to move on to a specific kind of enumerable called a stream. So eager versus lazy. All the functions in the Enum module are eager. Many functions expect an enumerable and return a list back. All right, so back to our terminal here. We're going to go ahead and create an anonymous function and set it to a variable called odd question mark. And what's going on here is, so we're just saying f, and then so whatever value is passed in, we are going to get the remainder of that value, or we're going to see if that value is divisible by 2. Okay, and if it's not equal to 0, then it is odd. And then so end, and then so there we go, we have our function. And then we can go ahead and use enum.filter here. So enum.filter, and we can do a range of 1 through 3, and then we can automatically pass that into our function here. And now filter is anything that, so when odd is true, it's going to return the value. So we're going to get 1 and 3 back, but not 2. So now we get a list back 1 and 3. So this means that when you're performing multiple operations with Enum, each operation is going to generate an intermediate list until we reach the result. So that's what eager means. It's each operation is returning a list until you get to its final result. So as you can see here, we'll go ahead and walk through this actually. So back to the terminal, I'm going to clear this just so we're at the top. So if we go ahead and say 1 dot dot and then 100 underscore, so this is 100,000. So the underscore is just for us humans so we can read the value easier. It is the same as doing that. It is just kind of a nice syntax to see what you're doing. And this is the pipe operator. And the pipe operator passes whatever value we're in into the next function. So now we're saying enum.map. And then with the ampersand, we are now shorthand versioning. We're grabbing the first parameter and we're multiplying it by 3 and then close those parentheses. So every time a value from this range gets passed in, we're multiplying it by 3. And then we're taking that result and sending it into the next function with the pipe operator. So we're saying enum.filter, and we're going to check if it's odd. And if it's odd, we are then going to pass it into the next function. So enum.sum. And so we're going to be adding all the odd numbers together here. And there we go. We get 3. My brain is hurting. What is that? 7.5 billion? Yeah. So the example above, the one that we just did, has a pipeline of operations. We start with a range and then multiply each element in the range by 3. This first operation will now create and return a list. So that list from this operation then goes into the filter, and it returns a list with 100,000 items. And then we keep all odd elements from the list, generating a new list, which will have 50,000 items. And then we sum all the entries. So list, and then a list gets passed into sum, and then we get our final result. The pipe operator, I don't think we've seen the pipe operator yet in the guide. So oh no, I lost my light. 1 second, guys. Okay, I'm back. My light charges, so I didn't have it plugged in, and I recorded a video this morning and then started this, so it died. All right, so the pipe operator is the cons operator and then the greater than symbol, and it's used in the snippet above in the pipe operator. It takes the output from the expression on its left side and passes it to the first argument to the function call on its right side. Its purpose is to highlight the data being transformed by a series of functions. To see how it can make the code cleaner, you can look at the example above written without the pipe operator. Okay, so let me pull up our terminal again. All right, so we see the pipe operator, right? Each thing here, we're just like doing one thing after another. If we were to write this without the pipe operator, it's just a bunch of nested functions, and it's harder to read because the last thing being performed, the enum.sum, is the first function you're going to see, right? So enum sum, and then we have to pass in enum.filter, and then we have to pass in our enum.map of 100,000, 100,000. And then we need to do our function in here. So this is the ampersand, and then we want to take the first parameter, which is the only parameter, and then we're multiplying it by 3. And then as long as it's odd, we're passing it to the filter. So this isn't bad, but I think it's a lot harder to read and follow than using the pipe operator, because it's just like, okay, this happens and then it passes it into this and then it passes it into this and, you know, so on. So what did I miss? Did I miss a parentheses? I feel like I missed something. Oops. IEX, let's try this. Undefined. Oh, dang it. I restarted the terminal. So I gotta rewrite my odd function. 1 second. Just a quick copy and paste. Okay, so there we go. I must have missed a parentheses. I can't see it. But anyways, so we get the same result as we did up above with the pipe operator. The pipe operator is just a little cleaner. I'm going to clear that. All right. So find more about the pipe operator here. You can read the documentation. The pipe operator is a heavily used operator in Elixir, so you'll see it a lot and you'll use it a lot. So it's pretty cool. All right, streams. As an alternative to Enum, Elixir provides the stream module, which supports lazy operations. So we can take the same example here. And so streams are lazy. They're composable enumerables. Let's go ahead and run through the example here really quick. And so we're going to do the same thing we did above, but we're going to use stream. So if I go, oh yeah, I deleted that. Time to retype it all. So if I have the range of 1 through 100,000, and then we pipe it into stream.map with the ampersand, so the shorthand function here, and we're just going to take our current number from the range and multiply it by 3. Close those parentheses and then pipe it into stream.filter. And then if it's odd, whoops, I can't type with my mic in front of me. Sorry, guys. And then we're piping it into the enum.sum. So we're doing the same thing we did with stream, but or the same thing we did with our enum.map and filter, but now with stream. And as you can see, we get the same results here. But the difference is, so in the example above, the range 1 through 100,000, and then the stream returns a data type, an actual stream that represents the map computation over the range. So this doesn't actually return a list. It returns a data type stream. So we're not actually creating a list each time. So furthermore, they're composable because we can pipe many streams together, and instead of generating intermediate lists, streams build a series of computations that are invoked only when we pass the underlying stream to the enum module. So streams are useful when working with large, possibly infinite collections. So it allows us to go through data until we get to what we want to get, and then we can use like the enum.sum and actually return a result. So that's pretty cool. Let's go ahead and play around with this. So if I just take the stream.map here and I pass that in, we're going to get the stream data type back. All right, so that's cool to see. And then we can also go one step further, and as long as we don't do the sum here, you'll see that we get another. So you can see that the functions, we have just a list of the functions. So the computations. So we're getting a list of every computation done in the data type stream, and nothing's calculated until, we hit the enum module. Hey, Nero, what's up, man? Happy to have you here, man. So that is what a stream is doing. And so, like I said, streams are useful for working with large, possibly infinite collections. Many functions in the stream module accept any enumerable as an argument and return a stream as a result. It also provides functions for creating streams. For example, stream.cycle arity1 can be used to create a stream that cycles a given enumerable infinitely. So be careful not to call a function like enum.map on such streams, as they would cycle forever. So let's go ahead and play around with that. So if we do our, let's clear this. I just like things at the top. So if we're going to set a variable called stream, and we're going to call stream.cycle, and then we're going to pass in a list of values 1, 2, and 3. All right. And then when I hit enter, we're going to get our stream data type back, right? And what we can do now is we can use the enum module and do the .take and pass the stream variable in. And we can say we want the first 10 items from this stream, and it will return the first 10 items. And as you can see, it's just 1, 2, 3, 1, 2, 3, and it's just repeated because we used stream.cycle. On the other hand, stream.unfold can be used to generate values from a given initial value. All right, so let's check that out. So if we do, we're going to set another variable stream, and then if we do stream.unfold and we pass in hello, we can try to pass in, let's see if I can type this. No. We can do that. I don't know how to type those fancy L's. We talked about this last time, and I also forgot what language it is. Maybe it was Polish. So we're going to just pass in hello, and then we can do the ampersand for shorthand to pass in, and we're going to just do next underscore code point arity1. All right, so when we pass this in, we're getting our stream back, and then we can say enum.take, and we can pass in our stream, and we can say we want the first 3 code points of hello, and we get H, E, and L in a list. All right, so another interesting function in the stream is the stream.resource arity3. Yeah, okay. Which can be used to wrap around resources, guaranteeing they opened right before enumeration and closed afterwards. Even in the case of failures, for example, file.stream arity1 builds on top of stream.resource arity3 to stream files. All right, so let's see. We can do a file.stream, and we can get the file stream, and then we're going to get the first 10 lines from it. So if I open up my terminal, I'm going to just close out of our shell for a second and cd to our desktop. And let's go ahead and just create a file here. So touch, we'll call it stream.text. And if I vim into that, so stream.text, I'm going to go ahead and go to the source code of this page, and I'm just going to copy the raw file, and we'll go back to where we were. So we're down here looking at file.stream, right? And so if I go back to the terminal and I just insert all this whole enumerable and streams section, right? And then I'll save this file. And now if we go back into IEX, I'm going to clear this to put it up at the top. So if we now do file, so I'm going to save it to a variable again called stream. And if we do file.stream lowercase, okay. And if we pass in our path to this file, so I'm going to just drag this file into my terminal for the path so I don't have to type it, and close off those double quotations and the parentheses here. When I hit enter, we're going to get a file.stream back. We know the path of the file. We know the modes here. So it's raw, read ahead, and it's binary. Raw is true. And now we can do enum.take like we did before and pass in the stream and say we want the first 10 lines, and it will return the first 10 lines to us. So the example above will fetch the first 10 lines of the file you have selected. This means streams can be very useful for handling large files or even slow resources like network resources. That's pretty cool. So the enum and stream modules provide a wide range of functions, but you don't have to know all of them by heart. Familiarize yourself with enum.map arity2, enum.reduce arity3, and other functions with either map or reduce in their names. And you will literally build an intuition around the most important use cases. You may also focus on the enum module first and only move to stream for particular scenarios where laziness is required to either deal with slow resources or large, possibly infinite collections. So one thing I want to touch on is Alex Kotmos. I had him on my podcast, and he wrote a book called Elixir Patterns, and he touches on the enum module. And he described it the best way that I've ever seen. He broke it into 3 categories. He said, of the enum module functions, you're either cleansing data, massaging data, or summarizing data. And I just thought that was really good. And then he broke down into map and reduce. And just like thinking about those 3 categories, it really helps you think about when and where you would use particular functions. And I really like it. So if you want to support an awesome author, you should pick up his book. It's worth the read. It's Elixir Patterns by Alex Kotmos. Highly recommend. And yeah, that kind of leaves us at the end of this section. So next we'll look at the feature central to Elixir, processes, which allows us to write concurrent, parallel, and distributed programs in an easy, understandable way. So processes will be our next live stream, and we'll be doing that on Thursday at 1:30 p.m. So that'll be a lot of fun. And thank you guys so much for tuning in, and I will see you next time. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in. Later, guys.